Hi guys, so at this point of time we will continue with the connection details for the warehouse. The last connection detail we need to do in this session is the base plate connection details. But before we start designing the base plate connection detail, we need to design the footings, or just to model the footings in place to start with. If I go to the floor level layout, I need to go to structure, isolated footing, and the footing specification here 17 by 17 by 900. There's nothing specified for the short columns, so I'll assume 1200 by 1200 by 900 for that one as an assumption. So we've got 18 by 1200 by 450 deep. That's not what we wanted, so we can just edit type and we go to here, check if we have our size. We don't. Duplicate and we call it 1700 by 1700 by 900. Delete that too. Press OK. So the depth will be 900. Both sides will be 1700. Press OK. Those will be located obviously in the center of these columns, in the intersection between the grid lines. This first one. Maybe I'll add another one here. All I can do is just press escape a couple of times, select them both and copy them. Got multiple and constraint ticked. Now for the columns, the smaller columns on the short wall, we will add a new footings there, and that will be slightly different, 1200 by 1200. So I'll duplicate, change the name to 1200 by 1200. By 900 deep. Press OK. I'll change those to 1200. Just rename it, just delete that 2 at the end. Okay, and press OK. Apply those in the center of the column this time. So rather than in the center of the grid, make sure they set in the center of these columns. I can just add one here and one there. Select these two footings and I can copy them. Okay, so made a mistake here. This is in the wrong location. I can just add isolated ones for these columns. It's done. Okay. Let's look at it in 3D. So these are the specs of these footings. They're sitting from the finished floor level, obviously down with the depth specified on them. Now our next step to start providing the base plate connection details for these footings. So if I just press on the column and go to structure, obviously the column and the concrete here will be connected. Well, it's enough just to press on the column and go connection. That will straight away provide connection at the bottom of that column, and that will detect that I'm looking for the base plate details. So we'll go to base plate connections. That will provide a generic base plate, and we'll do the usual edit type, edit. So the thickness, let's read the specs required for the base plate. So we've got a 20mm thick plate with 8 M20 hold down ports, 500mm long. the base plate to be sitting about 30mm from the top of the footing bed to allow for non-shrink grout. And we already did the footings, so what we need to know is just 20mm thick plate, 8 M20 bolts. So our base plate thickness is 20mm. The layout of the size of the base plate will be determined by projection. We're not going to specify a value. The column shortening, so it's asking us, do you need to do any shortening for the base of the column? So if I look at the side of the column here, the bottom, now currently it's been shortened already by the thickness of the plate, 20mm. This is by the plate thickness, but what we need to allow for another 30mm for non-shrink grout. So we're going to enter a value rather than 20mm only, and we will enter 50mm to be shortened, 20mm for the base plate plus 30mm space for the non-shrink grout. The direction of the base plate, we'll choose it by column. Switch beam end, that means we are working at the base of the column. If I click on this, that will go to the top of the column. I don't see the value of this option here. Regardless, let's go to the base plate dimensions. So it's asking how much the projection do you want to apply. Do we need to apply equal projection on all sides? We don't. Now we need 20mm diameter bolts or hold down bolts we are using. 20mm, the edge distance for those is 35 rather than 42, if you remember. That's from our PDF here, from the edge distances, that specification that we looked into. But if I look at the bolts here, just so you know, my plan is we need to have one bolt on the outside, another bolt here, the same thing on these sides. So we'll have 2 bolts here on the outer side, 2 bolts inside the flange, another 4 bolts on the other side mirrored to that side there. So I need to have a bolt here which should have 35mm each side of it. So that means I'll provide at least 70. So just let's keep it at 75 or 80mm. Just that would be at least the 35 from each end. So I'll keep it 80mm. That's projection 1. From this side, projection 2 is the same, 80mm. Now on the shorter sides here from this direction, what we need to allow for a short projection here, just enough for the weld to go around. So when they weld the base plate to the bottom of the column, so they can have enough space here to weld. So I'll provide just 10mm on either side. So that will be enough, guys, just to apply weld on both sides. Don't stress about the bolts now. We are just working on the plate for now. We will rearrange our bolts in these coming options here. The plate corners, are we going to chamfer or to cut these plate corners? Sometimes you have 2 columns next to each other and their base plates, because of the extra space the base plate it takes, the base plate needs to be chamfered or cut. We don't have this scenario, so we're not going to do anything for the corners. Now we got to a stage we need to specify our hold down bolts, the bolts for the base plate. So the first thing is choose our Australian hold down bolts under H. Holding down bolts, and we're looking for 20mm bolts. Now if you noticed, for the hold down bolts we didn't mention anything about 8.8 grade or structural grade. That's for a reason, guys. Usually these bolts, if I look at it from this side here, because these bolts are embedded in the concrete in this here, I'll change it to be 500mm so you can appreciate what I'm talking about. So these bolts here will be embedded into the concrete. We will have about 50mm, as we agreed, above the concrete. A bit more than 50mm, say 80-90mm above the concrete projecting out. Now think of that when we're installing the column, these bolts are already embedded into the concrete. If I choose them to be 8.8 grade, the one disadvantage with the higher grade bolts, they are very brittle. They break quickly, so you can't bend them. You can't bend them too much. You can, but not much. Otherwise they'll break. They are very brittle. Okay, they're very strong in tension, and the same thing goes for shear, but they are very brittle. If you try to bend them, they'll break. So that's why usually we use the standard grade bolts for the hold down bolts. Don't be surprised to see that. The assembly just not with washer, and the length we agreed 500 millimeter based on our specification. Now for the hole tolerance, if we are looking for any tolerance for these holes, so when they create the Splice plate, they have to make these holes on the Splice plate. It's showing here 8 millimeters. In Australia here, we for the Splice plate, and specifically for the Splice plate, we choose 6 millimeter tolerance, which is very generous comparing to, if you look at it here, for anything else, if we have up to M24 bolts, we have 2 millimeter tolerance. So at 24 and below, 2 millimeters, so we create a hole of 26 millimeters. For any bolts above 24 millimeters, we would choose the 3 millimeter tolerance. So for 30 millimeter bolts, we would choose 33 millimeter hole, or we would drill a 33 millimeter hole. Now for the base plate, mainly for the base plate, and just to help with locating the columns and making sure that the columns are square and plumb, what we call them, they go vertical. We allow up to 6 millimeter holes. Okay, we allow up to 6 millimeter tolerance on the holes. So that's the maximum. Otherwise, look, there's another clause in the Australian. This is from Australian standard, from AS 4100. And there's another clause there that says you can allow for larger holes, but that means you need to allow, or you need to add structural washers. So we add thick, about 8 millimeter thick washers, plates, small plates, just to compensate for that extra size we created. So there's no indication for us here. We will allow for 6 millimeter tolerance only, the standard. Now for the, there we go, that's the washer plate specification. If we chose for larger hole diameter, we can create a structural washers to sit underneath these nuts. Now we get to the stage we need to specify the arrangement for the hold down bolts. It's slightly different than the other connection. So the first thing it's asking you, how many rows or columns, you would say, of these bolts you have parallel to the web. See, it's parallel to the web here. You can't see it also. Anchors parallel to the web. How many of them? Look at it. This is the web plate. We have 1, 2. So we'll keep our 2. And it's asking what's the intermediate distance? What's the distance between them? This is too much, obviously. And if you noticed from all the other connections that we've done, we chose 120 was good measurement between those. Was sitting good within the section, so 120 is good. Offset from the center, do I need to offset them this side or that side? So if I apply, for example, 10 millimeter offset, you see they will move to one side, so we don't need that. We'll keep it at 0. Now we don't have any group 2, because if I created those on one side and offset them by a certain distance, I can create another group here. We don't have any other group parallel to the web, but we need to add some bolts here and on the other side. So we'll move on to the bolts or anchors parallel to the flanges. Number of those, so this is the current anchors we have. We need to add another 2 bolts on this side here. There are too many ways of doing it. I can either move all these bolts to be on one side and then create another group on the other side, or I can create these 2 groups here close to the outside and then measure a distance to the inside, or close to the center and measure to the outside. Let's try these groups here close to a distance here. So I need, if you remember, I will have my ports here at 35 millimeters, and that will allow another 35. I will have the flange thickness, and then if I can have another 35 or 40 millimeters, that'll be great. So sorry, I'll say it again. We have 40 because we chose this as 80, 40 millimeter each side of the bolts, and then the flange thickness, then 40 millimeter that way. Will be clearer after I finish the design. So let's choose for the first distance here. Let's say 300 millimeters. That's the distance between them. That's still to be more. 420. That looks good. So I'll choose maybe 410. Perfect. And now I'll choose the second group to be both sides of that, made of one port on each side. Give it some time to update. That's it. And the distance between them is 100 millimeter or 102. Okay, I can just make this 100. That should be sufficient. I can go and, so let's remember those. I can go and just check these measurements and see what adjustment that I need to do. If I go to the site view, this is the one, side view, I can just measure from here. Now what we need to measure, this is the base plate. If I look at it from the center of this bolt here to the edge of this base plate, I've got now 39. I need to move it 1 millimeter to the inside. That's still within our tolerance, because if you remember, our tolerance is 35 millimeters and the distance between them currently is, should be 100 millimeters. Now if I look at the distance from the center to the face of the column is 41. So if I just move the entire thing to the inside 1 millimeter from each side, that should do the job. That should give us good measurements. So let's go back to our connection here. We can fix it. As I said, guys, for each one of those you have to spend a little bit of time on the first connection, and then you can duplicate this to all connections. So if I change this to 408, that will make it 40 millimeter from the outside. Okay, what I've done, I just reduced that distance here by 2 millimeters. That shifted the entire group inside 1 millimeter this side and another millimeter that side. So that will do the job for our connection. And then what we need for the weld, we use fillet weld, which is continuous weld. That's what we are after, 6 millimeter weld. We will talk about weld in more details down the track. Now we have additional settings here for stiffener, gusset plates, and all of those accessories we may add to a base plate. If I look at it from the side here, just to show you. So we may add some gusset plates when we have larger plates, so we can improve the strength of this plate. We can add some gusset plate on all sides. We don't need them for here. We may add some shear. We may add some shear stud, what we engage into the concrete here, that will help into resisting shear forces, lateral shear forces. We don't need any of this design here. One of those things that we may need to add, the grout, there we go, on the holes. We can add some grout holes because we're being told that there is grout of 30 millimeters. Simply, this is just, if I look at it from the top, after we install this base plate, and that's sitting, we're sitting on top of the concrete 30 millimeters, we box around it, so we enclose this space of that 30 millimeter, and that's why we have a hole here of 19 millimeter diameter, for example, at an offset of 50 millimeters from the center. There we go, that's the hole there. So this hole here will allow us, will give us the space so we can inject the grout underneath and vibrate this box around it to make sure it's all filled underneath the column. And that's it for the base plate. So we go OK, and OK, go back to my 3D. This is our base plate here, meeting all the requirements we've been asked for. Then the usual, just right click on it and propagate connection, and that will create the same base plate for all similar size columns. Let's create another base plate for this column here. So the same, I'll do it quickly this time. So we've got, it's a 310 UV, go structure, connection, and I'll choose the base plate, edit type, just make sure that we chose the right base plate here, the base plate we need to choose. Okay, so this is the base plate I've modified. That's fine, we can modify it again. So we'll go to edit, look at it from the top. So it looks like this place here, edit type, and we edit that. Projection, that's the shortening, we'll keep it the same. Projection 8, the same details. Now all what we have to do, if you notice that the anchors were sitting outside, so I'll go to the anchors here and change those to say 300 millimeters. So it seems by mistake I forgot to, this is the disadvantage guys of what I was warning you about, that you need to duplicate your connections rather than rename them straight away. So it looks like I forgot, that's why now it's applying this change I've done for all the base plate. That's why it's a good thing for all of you guys to remember, duplicate your connection before you rename it. Okay, you rename it and change it. So we'll just edit type again. For some reason it's just showing the larger columns. Just push it to change a bit. This is the problem. Still showing the larger columns. What I'll do, I'll cancel this, delete this connection here and go again, 310 UB and connection. I need it to be the base plate. Not good. What about this one? Not good. That's fine. I'll work with this one to modify it. Shouldn't be a problem. So we need this. If you look at it, we'll keep the base plate size the same. All I need to do is just move the anchors to the inside, and I would say by, I've got here, I would say by 60 millimeters to the inside. So 120 less than what it is. Edit type, and that's a good lesson to remember for the future, to rename, duplicate before you rename and edit. Unfortunately, until this modified parameter will be fixed, we can't do much about it. Okay, so I'll go to the anchors in this direction here. This intermediate distance between the anchors, which is this distance here, I'll need this distance to, yep, I'll need this distance. We said we reduce it by 120, so instead of 300, I'm going to choose 180. Let's choose that. Let's try it. Looks okay to me. If I just isolate that, looks okay. So we can move it a little bit to the outside by maybe 5 millimeters to the outside. This plate here looks in the, this port here looks in the center, which is fine, so we shouldn't worry about it. That should be good enough. Now what we can do, just look at it from the corner and look at the entire structure and just propagate this connection. It's propagating these connections to the other columns in this direction here, and that's what we're after. Okay, so this will conclude the base plate design. We learned something very important, guys, because we agreed that this function is not activated and we are doing the edit from here. As you've seen, if I edit a connection, will be permanent edit on this particular project, by the way. On other projects it won't be, so now we can't reuse this connection in the old configuration if you don't duplicate it before you start editing it. So the first step for anything, please duplicate it and then start editing for the connection. Alright guys, so we'll move in the next tutorial to start doing the customized connection details for this area here.